this video, we will discuss about special array 2. An array is considered special if every pair of its adjacent elements contains two numbers with different parity. You are given an array of integer nums and a 2D integer matrix queries where queries of I is from and to. Your task is to check that the subarray starting from ending at 2 is special or not. Return an array of booleans answer such that answer of I is true if that subarray is special. So what they are saying is that in the input we are given an integer array nums and we are given another integer array which is queries. Now what they are saying is that an array is considered as special when every pair of its adjacent elements has different parity. So parity meaning even and odd, right? Parity even and odd, right? So, if in a particular array there are any two adjacent elements which have same parity, then they are not considered as special. Same parity meaning if the adjacent elements are both even or both odd, right? Then in that case, that array is not a special array. Right. Now what we need to do is we are given some queries. In that queries, we are given a starting index and an ending index which denotes as the indices of the subarray that has to be considered from nums, right? So we need to find out that is this subarray special or not, right? So see, the first query is 0 to 2, which is this particular subarray. Now, what are the adjacent elements? 4 and 3 and 3 and 1, right? So in 4 and 3, 1 is even, 1 is odd. So that is okay. Then in 3 and 1, both are odd. So they are having same parity, right? So for this answer will be false. Then if we see next one, 2 to 3. So 2 to 3 is this particular subarray. So here this is odd and this is even. So this is a special array. So for this our answer will be true. Then if we see for this 1, 2, 3, so this is the subarray. Now here 3 and 1 is adjacent and 1 and 6 is adjacent, right? So 3 is odd and 1 is also odd, right? So for this also the answer will be false. So this array we need to return as our answer. We need to return an array whose size is equal to the query size and each element should contain the answer of that particular query. So this has to be returned as our answer, right? So now how do we solve this? So see, if we take each of the queries, right, and for each of the queries, if we do a linear search in nums that, okay, the subarray is starting from 0 and ending at 2. So you will start a loop at 0, you will end at 2, and within this you will check that is there any adjacent element that is having same parity. If it is, then that means it is not special, right? Otherwise, you will iterate up to the end, right? And if no adjacent elements were found with same parity, then you can say that it is a special array. You can write your answer as true, right? But the constraints that are given to us is that the length of this nums is 10 to the power 5 and the length of queries is also 10 to the power 5. So we should think of some other approach, some better approach, right? So see, what we can do is, since we know that we have the nums array which is not going to change, all of these indices are just subarrays of nums. So what we can do is that we can identify that at what all indices in the nums array is a violating index present. Violating index meaning a particular index which is having same parity as its adjacent element, right? So if you see, if let's suppose I create an array violating indices, right? Now here, so for the 0th index, we do not have any adjacent element, right? So we will consider the first index. First index will be compared with the 0th index, right? So you see 3 and 4. One is odd and one is even. So they are okay. They are not having the same parity. Then we will check index 2, right? So index 2, these two are having same parity, then that means this is the violating index, whatever is the current index. So we will push 2 over here, that at index 2 we have a violating number, right? Then we will check for this particular index. Now here this is odd and this is even, right? So they are not violating, right? So there is only one index in nums where the adjacent elements are having the same parity, right? Now that you have got this array, so see, we were traversing in nums starting from the start towards the end. 1, then 2, then 3, and so on, right? So if whenever we found a violating index, we pushed it inside this array, then what all indexes would be present inside this array, that will be already sorted in increasing order, right? Because naturally these indexes are in increasing order only. So inside this array also, all the elements will be in sorted order, right? And now since that we know that we cannot go into n into m approach, so we will have to think of something like n into m log m, something like that approach, right? And we know that the elements in this array are present in sorted order, so we can apply a kind of a binary search over here. Now how can we do that? So see, whenever we are given a particular query and we need to find out whether this subarray is special or not. So what we can do, the starting index given to us is 0 and the ending index given to us is 2, right? So this is the subarray. So whichever is the first index in our subarray, that will never be a violating index, right? Because the first element will never have an adjacent element, right? So we will always start from this index plus 1, right? Start plus 1 till the end. So we will check for index 1 and index 2. So if index 1 or index 2 is a violating index, we can say that for this query, our answer will be false. And if all of these indices are not present in the array, the violating indexes array, then we can say that the array is special, right? Now our range is 1 to 2, right? Range was 0 to 2, but we are taking start plus 1 till end. So our range is 1 to 2, and we need to find out that within this particular range, is there any number that is present inside the violating indices array or not, right? So in a traditional binary search, what do? That we only have a single number and we search it inside our array, right? In our sorted array. And whenever the number is less than the number that we are searching for, then we shift towards the right half. If it is greater, then we shift towards the left half. And if it is equal, then we say that we have got our answer. But here we do not have an exact number to search for inside this array. We have a range. Within this range, we need to find out is there any index that is present in this particular array or not, right? So what we can do is that since this is our array, so we can take our left and right pointer for this array. So left will be 0 and right will be equals to the violating indices dot size minus 1, right? And then we can apply our loop of binary search that while left is less than equals to right, what you do, you will find out the mid, right? So mid will be left plus right minus left divided by 2, right? So this formula we use for avoiding integer overflows, right? Now this mid, whatever we have got, this will be an index in this particular array, right? So let's find out the value. Let's find out the value. So violating index will be equals to, in the array whatever is present at the index mid, right? So this is the number that we have got, right? Now see, there are three possibilities. What are the three possibilities? That this particular number will either be lying somewhere over here or somewhere over here or somewhere within this range, meaning this v index will either be less than this start, greater than this end, or otherwise between these two, right? So when this particular index is smaller than the start, that means it is somewhere here, then we know that we should shift towards the right half, right? So we will shift our left pointer. When this particular index is somewhere here, that is greater than the end, then we know that we need to move towards the left half. So we will change our right pointer, right? And if it is not less than start, not greater than end, then that means it is within this range. And if this index is within this range, then we can say that we have found out a violating index which is present in this particular range. So for this, our answer is going to be not a special array, right? So what we can do is that we will check that if this v index is less than the start, right, then we will shift towards the right half. So we will move left to mid plus 1, right? Else if our v index is greater than end, then we need to check the left half. So we will change our right to mid minus 1, else it is present within the range. So we can return a true or false over here. So let us suppose that this binary search function is telling us that whether this particular array contains any violating index or not, right? So in that case, you can return a true over here that, okay, yes, there is a violating index present, right? And at the end, out of this loop, you can return a false, right? Then in your normal function, you can check that if, let's suppose the name of this function is found violating index, something like this, right? And then you can pass your start, you can pass your end, and you can pass your violating index array, right? So if this is true, then that means there is a violating index found. So you will take false, right? Else we will consider the answer as true, right? And as I said, in this start, we will pass start plus 1, right? So for each of the queries, when you would be running a for loop, that for auto query in queries. So inside this, your start should be query of 0 plus 1, right? And end has to be query of 1, right? So this is how you can do. And for updating this array, we can just start our loop from 1, we can go till the end, and we can check that if the current element modulo 2 is equals to the previous element modulo 2. If this is true, then we can say that they are having the same parity and we can push I into this particular array, right? So this is one of the approach to solve this problem. Now here, once we would be traversing in nums for finding out the violating indexes, which let's suppose takes m time, right? And then for each of the queries, we will be applying binary search, right? That binary search will take log m time. So this log m time is happening for all the queries. Let's suppose queries length is n. So this particular loop will be taking the time as n log m, right? So we can say that the overall time complexity of this code will be m plus n log m, right? M is the number of elements in nums and n is the number of queries, right? So now there is one more way of solving this problem. If I remove all this, so see, instead of applying binary search over here to find out, what we can do is that we can create another array, and in that particular array, at each index, we can store that from the starting till that particular index, how many numbers are there or how many adjacent elements are there which are having the same parity, right? Basically which are violating. So this will give us some kind of a prefix sum array, right? So see, what we can do is that we will create a prefix sum array which will be of the same size as the nums array, right? For the first index, there will never be any element which is violating. So we will keep it as 0 always, right? Then we need to move to the next element. Now we will compare it with its adjacent element, which is 4. Now these two are having different parity, right? So for this index, we will store whatever was present at the previous index, which is 0. So this 0 is denoting that from the starting till this particular index, there are no adjacent elements with same parity, right? Then we move to the next element. Now for this, you will see these two are having same parity. So for this, what we will store? Whatever was present at its previous index plus 1, right? So here we will store a 1. So this one is denoting that from the starting till this particular index, there is only one adjacent pair which are having the same parity, right? Then we need to check for this 6. Now these two are having different parity. So at this index also, we will store whatever is present in the previous index. So we will store 1 over here. So this is what our prefix sum array would look like. Now what we can do is that when we are looping inside the queries, right? When we are looping inside the queries, so this we will consider as query of 0 and query of 1. So whatever is the start and end, we can compare their values, right? So 0 to 2. So index 0 we have a 0 and index 1 we have a 1. So here it was 0 and here it is 1, then that means somewhere in the between there was a violating index found. So for this our answer will be false. Then we check for 2 to 3. So 2 to 3, at 2 we have a 1 and at 3 also we have a 1. Then that means within this particular range there is no violating index. So for this our answer will be true, right? Then 1 to 3. So 1 to 3, 1 is having 0 and 3 is having 1. then that means there is a violating index in between. So for this, our answer has to be false, right? So with this, we were able to identify the answer of each queries in constant time, right? Here we can simply check that if the prefix of end is equals to prefix start, right? If both of these are equal, then for this particular query, our answer will be true, otherwise it will be false, right? So with this, you would be running a loop in the nums array for finding out the prefix array, right? And then you would be running a loop for each of the queries where all the operations are in constant time. So for this approach, our time complexity will be order of m plus n. So we have reduced this log m to constant time, right? So let's quickly look at the code of this prefix sum approach. First of all, let's create a Boolean vector for returning our answer. Then we will create another vector for storing the prefix. So let's name it p, and its size will be equals to nums. Initially, we will keep all the values as 0, right? And for safer side, at the 0th index, we can keep a 0. Although we have already stored the default values as 0, so this doesn't make any difference. So then we will run a for loop of I starting from 1 and then I less than nums dot size I plus plus, right? Now we need to check that if nums of I modulo 2 is equals to nums of I minus 1 modulo 2, then that means these two adjacent elements are having the same parity. So in that case, at the index I in P, we will store whatever was the value at the previous index plus 1, right? Otherwise, we will store whatever was present at the previous index, right? So this will initialize our prefix array. Now we will traverse inside the queries. So for auto query in queries, and inside this, we will take the start and end. So start will be query of 0 and end will be query of 1, right? Now inside answer, we can push back that whether prefix end is equals to prefix start, right? And at the end, we can just return our answer. So let's run this code now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.